to do is make sure you plot all the points correctly. That way you can figure out what the sides are, these ones in black, and then what the diagonals are, the ones in red. My advice is to find the slope first, so we'll do that first, and that's going to be the change in y over change in x. Several different ways to do it. You can use the formula, whatever you want to do. But for instance, if we take the y value from h minus the y value from I over the x value. Now it's got to be the same x value, so the 14 and 2 have to correspond, same point, and then minus 7. Remember, this formula is on your formula sheet. So then you'll end up getting negative 3/5. The other thing you're going to have to do is find the length of each side. You might as well do that first. The reason I recommend the slope is because if you find the slope, that's going to tell you the length of the legs of the right triangle that you can then use to find the length by squaring them, adding them, and then taking the square root. And that will tell you the length. And the distance formula is also on there, and that's doing this exactly the same thing. 3 squared is 9, 5 squared is 25, so this length is the square root of 34. And then you just repeat. So for ID, you do the same thing. So 11 minus 1 over 7 minus 11. Now in this case, you are going to get something that's reducible. As a matter of fact, you're going to get 10 over negative 6, which is indeed negative 5/3. That'd be the slope. However, when you're calculating the length, like we've talked about before, you have to use the values before you reduce it. So you'd be using the 10 and the 6 to find the length. So then it would be 10 squared plus 6 squared, quantity square root, which yields the square root of 136. Now because you're going to be comparing these, you don't actually need to figure out the decimal or even reduce them, because you'll just be able to compare those directly. Now if you repeat this process for DE and for EH, you're going to discover that the slope of DE is negative 3/5, which should seem alarmingly familiar. And its length is also going to be equal to the square root of 34. Likewise, EH is going to have a slope of negative 10/6, aka negative 5/3, and then the corresponding length will be the square root of 136. This tells you stuff. We'll talk about what that means here in just a sec. And you just repeat the process for the two diagonals, HD and EI, which I haven't drawn in, but you can see if you connect non-adjacent vertices, that's what you'd get. So, for instance, 14 minus 1 over 2 minus 11, nice round numbers we're talking here, would be 13 and negative 9. Positive and negatives on slope are important. That would then mean the length would be equal to the square root of 13 squared plus 9 squared, which works out to be the square root of 250. And repeat for EI, which would mean that you're looking at 7 over 1, so the slope would be 7 over 1, aka 7, and the length would be 7 squared plus 1 squared, or the square root of 50. Now, for the diagonals, there is one other thing you're going to have to calculate, and that is going to be the midpoint. And you're going to want to calculate the midpoint of each one. Remember, the formula is available to you. To find that midpoint, you simply take the x values. So to find the midpoint, we'll do that up here where we have some space. And that is going to be, for HD, where are you, HD? There you are. 2 plus 11 over 2. So the average of the x values. and then the average of the y's. Please bear in mind you want to keep x with x and y with y. And that simplifies to 13 halves and 15 halves. And that would be the midpoint. Now remember, it is a coordinate, so make sure you have an x and a y, otherwise it's not a midpoint. Now if you calculate EI, the midpoint of EI, you're going to discover those are the same. So what we have is what? HI and ED are congruent. ID and HE are congruent because they have the same lengths. And then we also know that because they have the same slopes that HI is parallel to ED, and likewise ID is parallel to HE. So far, what have we got? We've got a, well, parallelogram. Adjacent sides are not congruent, but the opposite sides certainly are congruent. To top it all off, because the midpoints end up being the same, we know that the diagonals bisect each other, thus guaranteeing a parallelogram.